In this video, I am going to use the substitution method to solve this system of linear equations. This system has two equations and two unknowns, so we are going to use the substitution method to solve this. Before I solve the system, I am going to give you an outline of what is it that we get when we solve a system of linear equations. Actually, when we solve a system of linear equations, there are three things that can happen. First, so let's label it A, B, and C. So one possibility is that two straight lines, for simplicity I'm assuming a system with two equations, so two straight lines. So two straight lines can intersect at one point. In that case, we just have a unique solution. Case B, these two lines can be actually parallel to each other. That means they never overlap, they never cross, nor do they overlap like this one. In this case, they have no solution. And the third case, C, is here is one line, and there is another line that kind of overlaps with it. So it's going to be, I'm going to put dot on top of it. In that case, when the lines overlap, they have infinitely many solutions. Many solutions. So these are the three things that can happen. In one case, you can have just one solution, this one, single solution. In another case, no solution. And in the third case, infinitely many solutions. So in this problem, what we are going to do, we are going to find out which one of these three does this system fall under. So we are going to use the substitution method. So we are going to solve for y in the first equation. 5x minus y minus 1 is equal to 0. If I move the y to the right by adding y to both sides, I get 5x minus 1 is equal to y, or my y is 5x minus 1. Now I am going to take this y value and plug it into the second equation. It's going to be negative 10x plus 2 times y, but y is 5x minus 1 is equal to negative 2. Now negative 10x plus 2 times 5x is 10x. 2 times negative 1 is negative 2 is equal to negative 2. Positive 10x, negative 10x cancel out. That gives me negative 2 is equal to negative 2. But this statement is true regardless of the value of x and y. It is always true. So if you run into this scenario, what it is, you have the third case. That means you have two overlapping straight lines. When two lines overlap, you have infinitely many solutions. And I'm going to show you by doing some simple algebra that this second equation is actually exactly the equivalent to the first equation. It's kind of hidden in this second equation. So negative 10x plus 2y is equal to negative 2. I'm going to move the 2 to the left, then it's going to be positive by adding 2 to both sides. So it's going to be negative 10x plus 2y plus 2 is equal to 0. Now I divide both sides by negative 2. If I do that, I get the following. So divided by negative 2, divided by negative 2, divided by negative 2, and divided by negative 2. On the right hand side, 0 divided by negative 2 is 0. On the left hand side, this goes into this 5 times, so it's going to be 5x. Negative 2 goes into 2 negative 1 times, so it's going to be negative y. And negative 2 goes into positive 2 negative 1 times, so it's going to be negative 1. So from the second equation, we just got this. Isn't it the same thing as this equation? It's exactly the same thing. So in essence, these two equations are equivalent equations. So that means they have the same solution sets and they overlap, meaning they have infinitely many solutions. I hope that this discussion was helpful. Thank you very much.